All right, 2.3 is all about graphing linear equations. The linear equation that you probably remember the most is called Slope-Intercept Form. Slope-Intercept Form, which I will heretofore call SIF, Slope-Intercept Form. Now, you probably remember y equals mx plus b, where m, of course, is the slope. Just got done talking all sorts of stuff about that. And b is the y-intercepts. Now, I like to write b as an ordered pair. I like to write it as 0, comma b. Remember, the y-intercept is where it crosses the y-axis. So anywhere it crosses the y-axis, no matter what, the coordinate is always 0, comma something, right? In this case, b. All right, slope-intercept form. Let's do a couple of examples now. Example. We're going to graph y equals 3/4 x minus 2. So, before we get started, the slope, of course, is 3/4. B, the y-intercept, is going to be the point 0, comma, b is, don't forget the minus is a negative, -2. So we're going to graph this. And through the miracle of technology, I can paste a graph right here as part of my notes. I think I gave you all some graphs that you could use. Just do that on a separate graph. So the way that we graph this is, first you start off with b. You start off with the y-intercept 0, -2. Put a dot right there. Then you use the slope to find more points on this line. Now, slope is rise over run, so we're going to rise 3, 1, 2, 3, and run 4, to the right 4. Now, our slope is positive, so our line should be positive. Double check that your line is positive, and then make some more points. Up 3, right 4, 1, 2, 3, oh, 1, 2, 3, 4. What if I was to go down? What if I went down 3? Down 1, 2, 3. Down is negative, so then I'd also have to go negative again. I have to go left 4. 1, 2, 3, 4. Down -3 divided by left -4. Negative divided by negative is positive. Keeps us a positive slope. Then bust out a straight edge and draw a straight line. Clearly, I did not bust out a straight edge. Maybe I should go try and find one. Good. All right, so tell you what, if you like, now you can press pause. Now you can graph this on the same graph or on a separate one, but try graphing this one. Y equals -3x plus 4. And just for fun, I got 2 more for you. How about y equals 7 and x equals -3? One of these you should be able to do. 2 of these you might need to think about for a second, but press pause and give them a shot. All right, so the slope here. Oh my goodness, give me a hard time. The slope here is -3, and b is the point 0,4. So plot the point 0,4. The slope is -3. Now remember, this is rise over run, so this is -3 over 1. We can make an integer a rational number if we need to, and then this describes us rise over run. So our rise is -3. Go down 3, and then positive 1, so go right 1. Make sure your slope's got a negative slope. What happens if I go up 3? Then I gotta go left 1. Up 3, left 1. So you graph all these, get a straight edge. I thought I had a straight edge. Huh. Well, that straight edge doesn't work. I tried to use my iPhone. It seems the metal's not letting me draw a straight line. Anyways, yeah. So this is the blue one. Should look like this. This one, the y is equal to 7. Some of you may remember that, we'll come back to the slope. if you don't know what something looks like, a lot of times it's good to make a table. And we can pick a value for x. How about -1, 0, and 3? I'm just making up points. If I plug these in, the y value is 7. 7. When x is 3, it's still 7. So check this out. Plot these points. We got -1, 7, 0, 7, and 3, 7. You can see that this is going to be, oops, a horizontal line. This is a horizontal line. So the slope of any horizontal line is 0. And the y-intercept in this case is 0, 7. In fact, check this out. This actually says y(e) equals 7 plus, what would be the coefficient in front of x such that x would disappear? It would be 0. You can see that y equals, here's mx, 0x plus b. Alright, so if this one's a horizontal line, chances are this one, let's see, let's pick some values for x. What's some values for x? Pick a number. It might be wrong, because the only one that you can pick is 3. -3, -3, -3. And then we can put in 4, 2, 9, 7, whatever. It doesn't even matter. No matter what, x is always -3. Everywhere along here, x is -3. So this is a vertical line. So review of slope. What's the slope of a vertical line? Undefined. Oops. And the y-intercepts? Where does this line cross the the y-axis? It never does. Or not y, sorry, b. B does not exist for a vertical line. It does not have a y-intercept. All right, so graphing the slope-intercept form, that should be review. Here comes some new stuff. Next part we're going to do is graphing. I should use an R, shouldn't I? Graphing using intercepts. Graphing using intercepts. Another form that is useful is called standard form. Standard form. Standard form is capital AX plus capital BY equals capital C. Oh, standard form I will call SF. Capital AX plus capital BY is equal to capital C. You've seen this form before, I'm sure. 4x minus 3y equals 12. Now, don't write this down. Put your pencil down for just a moment. But check this out. The way that you're probably tempted to graph this, if I said to go ahead and graph this, you would probably want to go and get y by itself first. So you would subtract 4x from both sides. You would have negative 3y is equal to negative 4x plus 12. Or 12 minus 4x, whatever you like. Then you would divide by negative 3, and you get y is equal to positive 4/3 x. But then you also got to divide the 12 by negative 3 as well, right? You get negative 4. So then to graph this, you would put in your grid here. And you would plot the point negative 4 with a slope of 4/3, up 4, right 3, because of positive slope, or down 4, left 3. Which one am I at? This one. And graph a line, right? Well, here's the thing. That's booty. That's too much work. It's way too much work. I'm going to show you using intercepts. Intercepts are going to be important here. Check this out. We're going to make two different things. We've talked about one intercept extensively. Oh yeah, if you haven't yet, go ahead, pick up your pencils. Let's do this. One of the intercepts that we've talked about is the y-intercepts. And what are the coordinates of any y-intercepts? Y-intercepts are always 0, comma, something, right? And then the other intercept, which we haven't talked about yet, are the x-intercepts. Now, look at the x-axis. No matter where the x-axis is, wherever it crosses the x-axis, the coordinates are always something, comma, 0. All right. So here's what we're going to do. We're going to substitute x0 in for the equation. So you got 4 times 0, which is 0. So what you're left with now is negative 3y equals 12. So what is y? Y is negative 4. So we're going to plug that in inside of here. So we got the point 0, negative 4. And then the x-intercept. X-intercept, we have 0 something y. So we have 4x minus, well, 3 times 0 is 0. 4x minus 0 is 4x. So 4x equals 12. See what we did there? We plugged in 0 for y, makes that term go away, and you get x is 3. So the x-coordinate here is 3. Now you plot those 2 points. You got the point 0, negative 4, and you got the point 3, 0. And I don't know if you recall from that quick thing that we did before we did it with the intercepts, this graph looks just like that other one, right? And you can figure out the slope if you want to from here by putting these 2 points. Going from here, it rises up 4 and it runs 3. It's positive, so our slope goes up 4 over 3. Our slope is 4/3. If you need to figure out the slope, just graph it like this and then count it off. One more quick section, vertical and horizontal lines. Vertical and horizontal lines. Horizontal lines. Always have the equation y equals some number. If it's y is equal to some number, it's going to be a horizontal line like this. A vertical line. A vertical line always has the equation x equals some number. Alright, if there's only one variable, be it y or x, it's going to be a special line. It's either going to be a horizontal line like this one, or if it's x is equal to a number, that is going to be a vertical line. And here's one thing I want you to remember. Equations always graph as lines. Equations always graphs as lines or curves as we keep progressing throughout this year. But here's the one thing that I need you to know. Equations are never a point. Alright? Now, the reason why I put this here is because x is equal to a number. A common mistake is that people like to just plot a point. Alright? Points are always going to be ordered pairs, x, comma, y. They're never going to be an equation. Equation is always going to be a line or a curve. Alright, so that concludes these notes. Bring your A game tomorrow. Smith out!